Okay. No more x comma 1. On. No more f of x equals y. But you can keep it in the back of your brain. But a big cause of confusion for this unit is when students think x's and y's. Okay? We're going to get into physics. We're going to get into motion. This used to be sprinkled throughout the entire first semester, but kids never really got it. So I left it out of the first semester and condensed it into this one unit so we can really dive in hard and really understand what's going on. You might not get it after this first lesson, but hopefully by the next lesson and the next lesson, I have 5 lessons in this. I slowed it down from last year. Hopefully we're going to get it by the time we're taking the test, okay? A lot of people after this unit are saying, I wish we did this before I took physics. I think I would have understood the motion unit in physics better if I learned this first, okay? All we're talking about in this unit is one situation only. A dude is moving left and right on a number line. We'll call it an x-axis. This is it. This is all that's happening. The entire unit, this is all that's happening. Okay? But here's the first cause of confusion. Like, what are our points? Well, we have a position at a time. The position is on our x-axis. This is the first big cause of confusion. Your position at a time. Let's say, I'll start over. Yeah. We arrived here. At the 5th second, at this moment, this dude is located at position 2. We label this as t equals 5, position 2, as the point 5, 2. Time is our input. Position is our output. Now, time is t. Position is a position on the x-axis. That messes up a lot of students. Just don't even bring in x and y. Don't even mention x, y. It's just time and position. Now, we are going to be focusing on equations that will give us our position at specific times. We are going to introduce ourselves to the position function. This is a position on the x-axis at a certain time. This point, let's say, came out of an equation, would be x of 5 equals 2. That is his position at time 5. What if the dude ended up here 4 seconds later? Can you please list off that point, both as a point and as a x of blank equals blank? Yeah. Time is 9 on the stopwatch, and here's where he's located. Okay, when time is 9, my position is -6. When time is 9, my position on my x-axis is -6. X of 9 equals -6. Okay, cool. Now, let's say the dude starts here, and then he moves that way. So let's say the dude has at time 2 or time 3 a position of 2, and then the dude goes this way, and maybe at time 4 he's at a position of -2. What happens? His position decreases. Cool? He moved left. Let's say the guy is going that way. What's happening? His position is increasing. He's moving to the right. What happens if the dude is standing still? He's not moving left or to the right. His position is constant. It's not moving. He's stopped. Cool. Let's put some numbers to it. Let's say at time 0, my dude starts here. Let's say at time 2, my dude gets here. Please list off those 2 points in both coordinate form and then x of blank equals blank form. In both point form and then x of blank equals blank form. Time 0, position is -3. My position at time 0 is -3. At time 2, my position is 5. X of 2 equals 5. Got it? What happens? Tell you this. Okay. He went to the right. His position increased by 8 meters over the course of 2 seconds. How was that calculated? Maybe you didn't think about it, but this is the calculation that you actually did. You took the final position, you subtracted the initial position, you took the final time, you subtract the initial time. What is this a form of? Tell your neighbors. Slope. Now, when you divide the two, you get this concept of meters per second, 4 meters per second. What is this? The slope of position, the average rate of change of position. How quickly position is changing. It's turned into a new word in the physics world. What is the quick short word in the physics world that we've used in physics classes for how quickly position is changing? Velocity. Now, if an average rate of change, which is a slope of a secant, gives us an average velocity, guess what? An instantaneous rate of change, Ryder, which will be a tangent slope of position, will give us an exact velocity. What does that mean? What does this mean? What I'm trying to ask you is, what is another word for tangent slope for instantaneous rate of change? Which means the derivative of a position function. How my position is changing. It's got a word for it that you've used in physics. Velocity. Now we have a new function. We have x of t, which we're talking about position at a time. Now we have v of t. Well, x prime of t equals v of t. Now, what is v? You're like, oh, it's velocity. Well, it's how quickly your position is changing. X prime equals v. Now, you don't believe me, don't worry. Like, again, we're going to get this by the end of the year, I promise. But here's something that you are familiar with, okay? Now, all freaked out. These were equations that were given to you. I am going to understand we are talking about, and we will be given equations with t's. Like this. Let's say I give you this equation. I say x of t is t squared plus 3t. X prime, the derivative. Since my t's are replacing x's, my derivatives of t's are just going to be like my derivatives of x's. There's nothing fancy going on. The derivative of this equation that I'm giving you, this x equation of t's, x prime is 2t plus 3. You guys okay with that? There's no dy dt, there's no dx dt. It's just like x's are now t's, right? Because my points are t, comma, position. Great. I'm going to take the derivative of this equation. Now, the derivative of x, I'm not going to say is 1. I'm going to say the derivative of x, this is an x of t, is x prime. Now, this xi is a number. It's an initial position. Its derivative is 0. This is a number. What do you say is the derivative of a number times x? It'll be the same as the derivative of a number times t. What would be the derivative of this? Write it down. The derivative of 3t is 3. The derivative of vit is v sub I. Okay? I'm not trying to confuse you. This is actually not important. It's just going to show you something that's cool. A is a number. A is a constant. Okay. What is the derivative of this number times t squared? Well, the derivative of t squared is 2t. So the 2 is going to come down, cancel with the 1/2. The derivative of 1/2 at squared is just a times t. I took the derivative of this equation, and this is my derivative. That's that. You were just told, guys, use this equation for position, use this equation for velocity. Now we know the relationship. Velocity is just the rate of change of position. It's just the derivative. Okay? Guess what? What if we're talking about the change of position? We already know velocity is the change of position. Let's look at how velocity is changing. Well, if we now have this new function v of t, I can list off 2 points. V of 0 is 1. My velocity at time 0 is 1. V of 2 is 11. What happened over the 2 seconds? Well, my velocity increased 10 meters per second over the course of 2 seconds. How did I calculate that? I took my ending velocity, subtracted my initial velocity, took my ending time, subtracted my initial time. I get 5 meters per second squared. This is the slope of velocity. Cool? The rate of change of velocity. What is the physics word that you've used for meters per second squared? Acceleration. Let's think about position velocity and acceleration. If the slope of position is velocity, I can write that here. X prime equals v. And if the slope of velocity is acceleration, what is the relationship between acceleration and position? The second derivative of position will equal the first derivative of velocity, which will equal acceleration. What you are going to find out is this unit, for the most part, we introduce something very, very key, which is really opening up the second half of calculus to you next class, is that physics in motion is just like F prime, and F double prime. It's the same. It's just physics attached new words for it. It doesn't say X prime, and X double prime. It says, oh, if we're talking about the rate of change of position, we're just going to call that velocity instead of always having to say the rate of change of position. Instead of having to say the rate of change of the rate at which position is changing, which is the second derivative, they're like, let's just call that acceleration. But it's the same as a function, its derivative, and its derivative. Okay? What we're going to do, these physics problems, are problems you've already done. They're just going to have different words. They're going to look different. If you can translate it into stuff you're familiar with, F prime, F double prime, it's not a big deal. It won't be that bad. It goes the other way too. Let's say you have A, and it's like, well, what's V and X? Well, you got to remember that it's like, okay, I can take an antiderivative. And I can take an antiderivative and work my way backwards. Now, towards the bottom, we have some space. Guess what? Do you guys remember sign analysis? Okay, please fill out this for me, and please fill out this for me. This is stuff we already know. I'm using F prime, I'm using F double prime, but then I'm saying, like, no, we're leaving it. Okay, if f prime is positive, f is increasing. Oh my gosh, can I get a line? They want to get rid of this program for next year. It's like this program called Smart Notebook. They don't want teachers to use it next year. And I'm fighting a good fight right now. I'm just like, don't you dare remove this from me. I love this program. Because they like says, oh no, we're using this now. It's like, no, I don't want to use that. I want to use this. All right. Ready? If f prime is positive, f is increasing. If f prime is negative, f is decreasing. What if f prime is 0? We stopped, right? Cool. If f double prime is positive, f prime is increasing. If f double prime is negative, f prime is decreasing. We could go the further step to talk about concavity. I'm just going to leave it here. Because, guys, what we're about to see should make sense to us, starting with x prime, which is equivalent to, what's the rate of change of position? The new word that physics used, v. Okay, so v is just a shortened word for the rate of change of x, the position. If v is positive and if v is negative, well, v is a derivative. So if x prime is positive, x is increasing. Now let's think about our dude moving on our number line. If position is increasing on our number line, what is happening? He's going to the right. If my position is increasing, I'm moving to the right. Is that cool? So a sign of a velocity actually gives me a direction. If velocity is positive, the rate of change of position is positive, position's increasing, I'm moving to the right, if we're talking about on the x-axis. If x prime is negative, x is decreasing. If my position is decreasing, I'm moving left. Okay, now we just discovered if velocity is negative, I'm moving left, because velocity is the rate of change of position. What if velocity is 0? I stopped. I'm not moving. I'm standing still. We are what's called at rest. Great. Now, guess what? A, which is v prime, which is x double prime, will tell us about v, which is x prime. So thanks, physics, for introducing these new words. It makes things complicated. The fact that they decided to call things velocity and acceleration kind of removes the connection of rates of change of position and rates of change of rates of change. So we have to get used to that. Acceleration is just a rate of change of a rate of change. Velocity is just a rate of change of position. If acceleration is positive, oh, my derivative of velocity is positive, my velocity is increasing. Means my position is concave up. I kind of don't want to put that down. I'm just going to leave it here. If my acceleration is negative, my velocity is decreasing. That's it. We're going to use that more when we're talking about speed later. Again, this, I want everybody to be like, okay, I get this. Does everybody get this? Because this is stuff we've seen before. Now, the questions we're about to do, you might be like, oh, this seems really weird. But what I'm going to try to tell you is it's just f prime, f double prime. Just believe me. You just got to translate it. Physics introduced these new words, velocity and acceleration. It's just a derivative and a second derivative. So, here we go. I'm not going to look at the questions yet. Not going to look at the questions yet. hide these, you know, I'm going to shrink these. I'll bring these back in a little bit. Here's an equation for a position at a time. Boom. We understand that points, for example, 1, which is -2, this point 1, -2 on this graph is a time and a position. Cool with that? Cool. So time is our independent variable. I'm not doing any questions right now. I'm just going to show you. Take the derivative, x prime of t, x prime of t. What is the derivative of t cubed minus 3t squared? Tell your neighbors, what do you think it is? 3t squared minus 6t. It's just the derivative like normal. There's x prime. But what did we just find? What is the rate of change of position? We now can say x prime, I have a velocity equation. What if I took the derivative again to get the second derivative, like f double prime? All I do is take the derivative of the derivative. What is the derivative of 3t squared minus 6t? Okay. It's a rate of change of a rate of change. It's a rate of change of velocity. It's a rate of change of a rate of change. It's an acceleration. You just found an acceleration equation by taking a second derivative. It is just f prime, f double prime, but physics says x prime is v, and they didn't tell you that. Physics says x double prime is a, but they didn't tell you that. Cool. Cool. Right? It's not that bad. So, how do we create sign analysis? Because we're going to have to. How could I create an x prime sign analysis, which is a v sign analysis? How can I create an x double prime sign analysis, which is an a sign analysis? What do I do to create a sign analysis? Take your derivative, set it equal to 0. Go. Give me a sign analysis of v and a. Give me a sign analysis of this and this. Yep. Yep. Okay. Guys, if you can do this, which is something we've done many times before, you can answer every question I give you. If you know what this means, you can answer every question I give you. If x prime is positive and negative and positive, you know x increases, decreases, increasing. You know you're moving right, left, right. If x double prime is negative and positive, you know that x prime, which equals v, is decreasing, then increasing. If you know the derivative of x prime equals a v, and the second derivative of x, the rate of change of the rate of change, is an a, and you could do this, stuff we've already done, you're going to be able to answer any question. Okay? Have you done this before? Is this familiar to you? Okay, now all we have to do is figure out what are they asking me in their crazy physics ways. So let's find out. Let's move our velocity to be up here. Let's move our acceleration to be down here. We have our sign analysis. We have A's equation. Let's move my acceleration sign analysis to be below this. Let's get our equations out, or our questions out, and let's start answering our questions. Okay. We got everything I need. Here's my first question. What is the velocity at times 2? Well, you have a velocity equation. You took the derivative. Plug in 2. You get 0. What does that mean? You have stopped. Your position is neither increasing nor decreasing. The derivative is neither positive nor negative. Sharp, I'm going to kick you out because Verma needs to pay attention. And you need to pay attention too. What's the acceleration at time 2? Oh, you have an acceleration equation. Oh yeah, that's just my second derivative. I get a of 2, which is the same as x double prime of 2 is 6. What does that tell me? If my acceleration is positive, my velocity is increasing. Now that's a loaded statement. Velocity is increasing. It doesn't mean accelerating. It doesn't mean speeding up. We'll talk about it more. When has the particle stopped? When does the particle stop? Tell your neighbors.
0.
Yeah, when the velocity is 0, because that's when the rate of change is 0. I'm neither moving left or right. I have stopped. When am I moving to the left? Oh, I know that. That's when my position is decreasing. What is my velocity decreasing? Yeah, for my time value, excuse me, my time value is less than 1. Now again, these are times. This is not x's. X's are now times, so all my times less than 1. Now here is a new question. This is a question we actually haven't done. And I'm going to change it to be 1 because it doesn't work out at 2. Am I moving towards or away from the origin at t equals 1? Okay, guys, back to my dude. There's the origin. We're not talking about the point 0, 0. We're talking about a position of 0. Okay. Now, let's say my velocity is positive, which means my position is increasing. Am I moving away or towards the origin right now? Moving away. Cool. Well, what if I'm over here and my velocity is positive, my rate of change of position is positive, my position is increasing? Am I moving towards or away the origin right now? Towards. What you have to find to answer this question is your location and how that location is changing. Find your position and find your rate of change of position. Find your position and your velocity at this time. Don't think you don't understand this. No, you're acting like it though. Yeah. Guys, what's your position at time 1? Find it. What's your position at time 1? I didn't tell you what it was. I actually found it earlier. But what's your position at time 1? You need to know your location and how it's changing. What is your position at time 1? Well, go back to your position, your F equation, and you get -2. Now, what does that mean? That my dude has a location of -2 when time is 1. This is a big thing that students mess up. This idea of this is just a time, this is a location, you're still in X and Y mode. Get out of the two-dimensionality of things. Just stick to right and left. Don't go up and down at all. It'll help you. Now, we need to know if my position is increasing or decreasing. I need to know if I'm moving to the right or left. What do I find? The rate of change of my position, the velocity at time 1. Oh, I know it's negative. I could find the exact value, but I know it's negative. What does that mean to answer the question? My position is here. My position is decreasing. My velocity is negative. I'm moving away. If you can take derivatives, if you can do sign analysis, these questions aren't that bad. Okay, what about this question? Let's skip this question. Let's go. No, let's stay with this question. Don't worry, we're perfect. Yo, what if you start with a velocity equation, but you're asked about a position? Ah, you're nailing it. Oh, V is just an X prime. It's just a fancy physics word because it's easier to say than the rate of change of position. So you're going to just say, instead of saying rate of change of position all the time, I'm going to say velocity. Instead of rate of change of the rate of change of position, I'm going to say acceleration. You just got to know that your position is your antiderivative. All right, so this is my position function. So I plug in 2 and I get 8/3. Wrong. Why do I say don't forget about this key thing? What's the key thing when taking an antiderivative? Plus C. That's the key thing. Don't forget, guys, when you go backwards, there is some unknown constant. But when given information, you can find the value of that unknown constant. You get 27 divided by 3, which is 9, plus C equals 5. You get C is -4. Oh, don't forget when going backwards, you need a plus C. Now you can plug in 2. Got it? So like going forwards, derivatives, sign analysis, good. Going backwards, make sure you find C's. You can still do your sign analysis if you want to. You can still do a sign analysis of this. You can still do sign analysis if you want to. Boom. This looks like such a crazy question. It's like, oh man, this is really tough. But all you need to do is understand, oh, acceleration is just another word for the rate of change of the rate of change of position. Sharp. Stop talking. Cool. That's the second derivative. Okay, great. One other thing you have to know is the initial velocity, initial position. Oh, that's my velocity at time 0. Whenever you see the word initial, assume it's your time 0. Okay, my initial velocity is 3. My initial position is 4. I remember that velocity is just another word for rate of change of position. Acceleration is a rate of change of a rate of change. It's just a fancy math word. We go backwards one step along the way from A to V. We find C along the way. We then go backwards again by taking an antiderivative, but understanding every step along the way. When going antiderivatives, you need to see. Now I have a position function, and then I can find any position after any time. After 5 seconds, I'm at 25 plus 15 plus 4. If you're copying this down, it's a waste of time. Understand what I'm doing and be like, oh yeah, I get it. Like write down on your notes, it's like, yo, remember plus C. Cool? Now, I might start you with a velocity equation, which means I'm starting you with a derivative. I don't start you with x, I don't start you with a, I start you with x prime. Well, it's like, it's okay. You can do your sign analysis of your derivative. You know how to take the derivative of that. You have a sign analysis of that. You can answer your questions by just finding equations and doing sign analysis of equations and understanding the translations of what you have. And I can also go backwards. It's just f prime. This is f double prime, derivative. This is f, antiderivative. Sign analysis, understand the meaning of it, answer your question. Okay, I'm not going to do it because you got it. But I'm going to give you this. Okay. It looks crazy. Oh, these are so hard, Mr. Metro. I hate physics. It's something we've already seen. That just needs to be translated and understood. This is the graph of V. What am I giving you? I'm giving you x prime. When is the particle moving left? When my position is decreasing, when my derivative is negative. Answer the question. Wrong. When is my derivative negative 2 to 4? Yo, that's like when is f decreasing? This is the graph of f prime. You know these questions. When is the particle stop? 0, 2, and 4. That's when my position is neither increasing nor decreasing, when my velocity is 0, when my derivative is 0. When is the acceleration negative? Oh, geez, I'm not sure. Well, I'm going to break out my sign analysis. And I'm like, okay, my acceleration negative. Oh, my acceleration is just my derivative of velocity or my second derivative of position. If acceleration is negative, that means velocity, again, this is f double prime, f prime, must be decreasing. You want to know when acceleration is negative? You have a graph of velocity. Look at when velocity is going down. It's stuff we've done before. It just has new words. When is your derivative decreasing 1 to 3? That's so bad? It's not that bad. It's like, I get it. I get it. That's the derivative. I understand my sign analysis. I'm good to go. Let me ask you a question. I'm going to ask both sides a question. Both sides. Remember those questions when I ask you, when is F increasing concave down? Remember that? Remember when I asked you, when is F decreasing at a decreasing rate? Do you remember those questions? What did you have to do to answer those questions? Do you remember? No. You guys remember when I asked you those increasing concave up questions? What did you have to do? Tell your neighbors. What did you have to do? Right. You had to look at both sign analysis at the same time. Yo. We're going to talk about speed. Mostly speeding up or slowing down. Speed is complicated. Speed is velocity without direction. It's the absolute value of velocity. Speed, always positive. You still have a positive speed, but your speed's decreasing, you're getting slower. That's the key. You're all over this. When is something speeding up? Tell your neighbors what you think when something is speeding up. You're going to be wrong. No. Acceleration is increasing is the derivative of acceleration. A prime. No. 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 When acceleration, you were wrong. Ready? Everybody says the following. When acceleration is positive, is where people usually go to, you must be speeding up. And for most of you and for most situations, you're right. Look, the guy's speeding up. But I'm going to give you a situation where my acceleration's positive. And for some of the time, I'm going to be slowing down. Watch this. Wait. Oh, he was not moving at all. Thank you very much. Okay. Negative velocity, positive acceleration. I just slowed down for that moment. Let me try to do it again. Ready? Watch, watch, watch. Okay. Negative velocity, my position is decreasing. Positive acceleration, my velocity is increasing. Look at what my velocity values are going to do. I hope this works. -9, -8, 7, 6, 5, 4, 3, 2, 1, 0. Would you say I was speeding up during those couple seconds that I pressed play? Yo, you can speed up with positive acceleration, but you can speed up. He's coming back, don't worry. You can speed up with negative acceleration. You can slow down with negative acceleration. You can slow down with positive acceleration. It's all about signs of both derivatives. It's all about both of our derivative sign analysis. Here is a situation. Your velocity is positive. I'm going to the right. Your acceleration is positive, meaning your velocity is increasing. Positive velocities that are increasing. Positive 1, 2, 3, 4, 5. It means my position is increasing at an increasing rate. Increasing concave up. I'm speeding up. But when your velocity is negative and your position is decreasing, if those velocity values are getting more negative, like -1, -2, -3, -4, -5, those are negative velocity values that are decreasing. You're speeding up. If B and A have the same sign, it's not that your acceleration's increasing. Your acceleration can increase from -2 to -1 to 0 to 1 and 2. That's increasing. It's not when acceleration's positive. That means your velocity is increasing. That means your velocity could increase from -5 to -4 to -3 to -2 to -1. That means you're slowing down. It means you're going in the same direction. It means your position is increasing concave up or decreasing concave down. Really stick with same signs and you'll be safe. So Sharp, you're gonna pay attention to me right now, and you're gonna understand it now. Ready? Acceleration is a derivative of velocity. If acceleration is positive, your velocity is increasing. Increasing does not mean magnitude gets better. Increasing means your values go up. Here's a situation of increasing. -4, -3, -2, -1, 0. Those are increasing values, Sharp. Let's say those values were velocity values. Would you agree that they are increasing? -4, -3, -2, -1, 0. Would you say you're speeding up? Thank you. I rest my case. I am right. Okay, cool. Don't say acceleration is not a magnitude. Acceleration being positive doesn't mean my velocity's magnitude is increasing. No, it means my velocity values are increasing. The rate of change of my rate of change is positive. Okay, then you're good. All right, so answer this question. Go. Go. Yo, guess what? This question is like, when is F increasing concave up? When is F decreasing concave down? That's it. Did you do that question before? Yep. Yeah, all you're doing is like getting your first derivative. Oh yeah, I know how to do that. Doing a sign analysis of it. Oh yeah, I know how to do that. I know, we already did this. Not negative, positive. All right, ready? When my velocity values are negative and decreasing. When my velocity values are -1, -2, -3, -4, 0 to 1. When my velocity values are positive and increasing, 2 to infinity. Those are velocity values that are going to be 1, 2, 3, 4, 5, 6. You can speed up going in either direction. This question, which seems so complicated, is essentially a question you've done before. It just looks different, and you have to understand, just because your acceleration is positive doesn't mean you're speeding up. Between 1 and 2, I will be slowing down because I'll be traveling to the left, but with increasing velocities that are getting towards 0. It would have been better